Hi guys, welcome to this session. In this session, I'm going to introduce you to NumPy. So NumPy is a numerical Python library for scientific computing, and what makes it different from the Python array is that NumPy arrays are faster and more user optimizable, and they give you better storage options as well. And they come with lot of inbuilt methods which helps you in data processing and computing. Now let's move further. So let's create a simple NumPy array. So first of all, you will need to import NumPy, and then you can use the np.array method to create a NumPy array. So common NP methods for arrays are np sort, np concatenate, ND array dim. So ND array dim is used to get the number of dimensions of the array, and just like that we have ND array size. So it is used to get the size of the array and the shape, and we can use the add.reshape method to reshape an array. So something like if you want to change an array that has 2 rows and 3 columns into 4 rows and 2 columns, then we can use array.reshape. And then we have np.non-zero, which is used to return the number of elements up to 5. Then common NP methods for arrays like array reshape, array transpose, array t. So just like that, here we are concatenating. So we want to concatenate x and y array at axis 0. So we can simply use this function, and let's move further. So array functions. So there are various array functions that can be used to get the value of array like minimum, maximum, sum, mean, products, and all. Now let's move further. So we want to reverse an array, so we can use the flip method. So our array is x, and here we reverse the array, and then we print the reversed array. So moving further, flattening the array. So we want to flatten the array x. So we just use the flatten method. Then we can also plot our array using the plot function. For that, we need to import the matplot library as well. Then after doing all the computations, we can save our file by using the save text method. And you can do many basic operations such as creating the matrices, doing various computations, creating a 2D, 3D array. So a lot of exciting things can be done using NumPy, and we will look more into Pytorch and NumPy sample practicals in our upcoming session. So thank you, stay tuned, and see you. Hi guys, so in this session we are going to look into the steps to install Pytorch in our system. So first of all, you go to the Pytorch official website, then you select the build and your OS, then package type and the language. Currently it's available in 3 languages: Python, C++, and Java. Then the compute platform. If you have sudo available, you can use sudo, or either you can use CPU. So here we have selected the stable version, Windows, pip, Python, CPU, and we have installed it in our Visual Studio Code by running this simple command. Now we will look into more functions and components of Pytorch in our next session. Thank you. Hi guys, in this session we'll be learning about tensors. So tensors are a basic component in Pytorch,
And basically it is a container of data with a rank. It's a number of dimension, size. Then it has attribute denoting how the data is represented. It can be created from NumPy arrays. And so before installing Pytorch, it is recommended that you have NumPy already installed in your system. Then tensor operations. So you can use tensors to perform wide number of operation, and it can be also used for various kind of computations and complex neural network models. These computations include matrix multiplication, dot product, linear algebraic function, correlational operation, pooling operation, and several others. Now, tensor arithmetic. Tensor arithmetic is used to define mathematical operations on tensor. This includes basic addition, subtraction, multiplication, division operation, as well as more advanced ones such as logical and comparison operations. So, Pytorch provides powerful tools for storing data in form of tensor. Through tensor operation and computation, user can construct complex neural network models. Hello guys, in this session we'll be learning about transform, which is a mathematical operation that combines data from multiple sources and transforms it into results that can be used for further analysis. Now, application of transform, it can be used for a number of fields from signal processing, image processing, computer vision, machine learning, data analysis, and many related fields. They can be used to change the properties of an image, signal, or to identify objects or features. Common transforms are Fourier transforms and Laplace transforms. Using certain type of transforms enables us to represent complex signals or images, some simpler functions or components. Now, computational complexity of a transform is determined by how many operations are required to perform the transform. Generally, linear transforms require fewer operations than nonlinear transforms. Performance optimization such as block processing can be used to make transforms more efficient. These methods limit memory usage. Hi guys, in this session we'll be learning about activation function. Activation functions play an important role in deep learning. So first of all, let's look into binary state function. The binary state function is the simplest type of activation function, returning either 0 or 1 depending on a certain input. This is used in binary classifier and logic gates. It is also useful for simple classifications. Then we have sigmoid function. Sigmoid function is smooth and nonlinear and returns a value between 0 and 1. It is used in logistic regression where it maps the input value to probabilities. Then the next one is ReLU function. ReLU stands for rectified linear unit and is a type of activation function used in deep learning. It maps negative values to 0 and positive values to the providing a nonlinear activation. Now the next one is hyperbolic tangent function. The hyperbolic tangent activation function or tanh is simpler to the sigmoid function, but the main difference is that it returns a value between -1 and 1. This allows for more robust classification. Hi guys, in this session we will be creating some tensors with Pytorch. So let's begin. So first of all we will be importing torch, and now let's write some simple tensors. Let's call it T, and T is a one-dimensional tensor. So adding the tensor method from torch. Okay, let's print it. Let's run it. here we have our first 1D tensor. Okay guys, in this session we will be doing some tensor operations. So let's begin. So first of all, we create a tensor, and to do that, we use the torch tensor method. Now let's make a tensor, and we have already created one tensor. Now let's print it out. Okay, now we can reshape this tensor. By using the tensor reshape method. Okay, let's run it. We can print the reshape tensor. This session we will be doing some tensor operations. So let's first initialize some tensors. So we have tensor 1 and tensor 2. Now once created, they should be of same length. Okay, now we are ready to check some operations. Hi guys, in this session we will be doing some transform operations. So let's begin by importing Torch. May take the system to add it. It may take some time to add it. Hey guys, in this session we will be doing transformers, and so let's begin. So first of all we import torch. Then after importing the torch, we import torch vision and we import transforms. Once done, we can create a tensor with a random value just to test it out. Now let's call it by random method available in the torch library. Okay, now let's define a sequence of transforms to be applied on the transform. So how do we do that? We do that by calling the transform and the compose method. Then let's apply a lambda transform and after defining transform lambda, we need to define a method inside this. So let's do that. Okay, so this needs to be we have some syntax error currently, so let's look into this. Okay, let's initialize it. So let's apply the transform to the tensor. Okay, we are having error currently. So there is an uncallable object. Okay, let me fix this. So here we are. Actually, it was a method error. Now it should work. Let's create the transform tensor. Okay, let's check for some syntax errors. Okay, so here we have the transform tensor. Now let's do some more operations on it, like adding a constant. So to do that, we can simply use our transform tensor, and then we can do some further additional constant operations. So let's do that. Okay, let's run it. So here we have the second transform tensor values by adding a constant. Now let's do further operations like multiplication. Now here we have the multiplication values. Moving further, we can do more operations on it, like taking the absolute value. Hi guys, so here we have value activation model. So this simple model in which we are like giving the input size, output size, and number classes. So we can initiate the model by giving the input size and output size, and then we can forward the network, and then we can give the tensor values. So next one is a simple feed forward network. In this we are using input size, hidden size, and number of classes. So here we are also initializing it using the relay activation function and the linear methods, and then we are printing it out. Hi guys, in this session we will be looking into Torch Studio. So let's get started. So Torch Studio comes with lot of models and examples. So one of the most common examples is Amnest classifier. Then we have Unit 1D, which is a convolutional encoder decoder neural network. Then we have Unit 2D. So we will look into all the models available one by one, and we will be also looking into the operator level graphs. So for here it's starting with X, then it's passing to convolutional neural network 2D, then ReLU, then again to the convolutional network 2D, then ReLU, then max pooling, then flatten, linear, ReLU, linear, log softmax, and output. So we will be importing the important modules from the torch. One of them is importing torch and then functional SF. Then we will be defining the channels. The channels are input channels and output channels. Then convolution per block, kernel size, and we will set the patch normal. Then we can use simple loops to add the convolutional layers per block. Then we can define various classes. And then we can finally define our class for the 1D neural network. So using the channels, depth, downscaling, merging features, then we can create a pathway, and then we can follow with our unit 1D model. So we can select the channel values, depth, feature channels, upscaling values, downscaling values, and build. In building we have many options available. For now we are using a scripted build. Then we have other examples also for unit 2D, Amnest classifier. For Amnest classifier we are using the same modules, and we are using two classes, and in our forward we are defining the ReLU and convolution values, and we are setting the dropout values, and then we generate our model. Similarly, we have unit 2D, and it follows the same structure as unit 1D, but here we will be giving extra layers and classes. Now we can check it on various values to see the output results. We can also see the matrices in our right panel. Now Torch Studio offers with number of data sets and ways to analyze it. such as image folder, ImageNet, in a Studio 2K, GMNest, Kinetics, PhotoTour, QMNest, rendered SP dataset, SPU, Simeon, Sun, SVHN, and so on. You can select any of these and you can analyze the datasets. You can also add custom datasets. Then you can import the dataset, export the dataset. In Torch Vision datasets, we have a VOC segmentation list for various types. Here you can see the parameters and the return values. This is simple view of the dashboard. You can see the validation metrics and all. So this is a Torch Studio dataset for random generator. We also have generic loader. So it is basically used for classification, segmentation, and the regression of datasets. It supports image, audio, and NumPy array files. A random generator returns randomly generated tensors. So these are some important dataset types: MNIST, image folder, kinetics. So kinetics is used for video datasets. Similarly, we have STL10. So STL is also very important dataset type, and it is used mainly for larger samples. Then we have Omniglot. So basically Torch Studio offers you with a range of datasets, various methods to analyze them and to see the matrices, and you can follow with your own custom datasets and train according to your requirements. Thank you for joining the session. I will